Well, welcome to our Safer World by Design webinar, the first one of the year. I have to make a couple of apologies to start. It seems like the camera system is not working on the GoToWebinar right now, so it's not that we're being unfriendly, but the camera just doesn't seem to be working right now. Maybe that'll fix itself by the time we get to discussion. And also, I have a bit of a cold, so if I'm sounding a bit muffled, it's because I have this cold. Um, what we'll do is we'll go through, as usual, some presentation on our topic for today, which is on incorporating work we've been doing over the last couple of years into a second version. And I should say it's a very early version of the second version of SaferSkin as a software tool. We'll also give some insights on what we're planning to add to that this year. And then we'll go into a demonstration on a couple of examples using this software, and you can also try it out yourself, and then we can have some discussion. And then you can post questions at any time in the chat or in the question box. You'll see those icons in your top menu. And then when we go into discussion, we can also open it up if you want to say something, ask a good question. Um, uh, we can also open it up, and you can just raise your hand, and I'll come back and facilitate that discussion as best I can. Usually, my role is to try to facilitate good discussion in these webinars, and we usually do have good discussions. So I hope we will have that today as well. So with that said, I'll pass you over to Pascal, who's going to start us off with the presentation part.
Perfect, and I take over. Good afternoon, everyone. My name is Pascal. I'm a molecular biologist working at Edelweiss Connect, and also I'm involved in the development of Safe World by Design. And I take over the first part of this presentation, where I am going to introduce you into some scientific basics of risk assessment. And today it's about skin sensitization assessment. Show you some principles, also guidelines which are underlined of those principles. In the second part, Tomasz will take over, give you further insight into the models, in silico models, which we have implemented in our application. And in the last part, we will do a step-by-step guidance through our application where you can follow along as well and immediately try it out. So in assessment, actually all starts with molecular mechanisms within cells. It is the basics in which prediction is built on. So you see here for skin sensitization, we have so-called molecular key events. Those key events are events which correlate the adverse outcome pathway. In this case, it is skin sensitization, and you can take them as a marker for a skin sensitization. You see here we have a first key event. Here it is, since it is the first key event, also the molecular initiating event. So it's initiating a whole cascade of events leading to the skin sensitization event. And in this case, it is the covalent binding of a chemical or a compound, a material, to skin proteins. So you have a compound which you might assess, and it's exposed to skin, it penetrates into skin, and then you have this first key event, the covalent binding of your chemical to cysteines and lysines of your skin proteins. For this key event, there exists an assay. It's the direct peptide reactivity assay, which you can use to measure if this binding happens. So it's not only the key event, but there is also an assay which you can use to measure this event. Afterwards, there will be an activation of keratinocytes. Keratinocytes are the most frequent cell type in skin tissue, and the activation you measure by gene overexpression measurements. There are specific genes which are known to be overexpressed during skin sensitization, and you can use this keratinosense assay again to measure those gene overexpressions for the second key event. The third key event is the activation of dendritic cells. This activation you can measure by the HGLAD assay, and here you measure actually the expression of CD54 and CD86, and you can use antibodies to measure this expression. You also have a fourth key event. This is T cell activation, but it is an in vivo assay, so you have the local lymph node assay which you can perform. But the whole approach of SaferSkin is to come away from in vivo studies. So we do not conduct the fourth key event assay, but we use data from it. So already existing data, it's important to use it and to implement it in the whole assessment process as well. And based on those molecular mechanisms, you can build in silico prediction models. As you can see here, we have direct nexus. Also, the OECD developed a toolbox, SaferSkin, multicase, and so on, which are mostly QSAR prediction models. QSAR stands for quantitative structure activity relationship, meaning if you have a compound, you take its 3D molecular structure, and then you say, okay, I have a certain type of structure, and for instance, at position 1, I have an aldehyde group, and then at this position, there is an aldehyde group, I have a specific interaction with a molecular event within cells. And based on this, you build your models, and then you can evaluate new models which have similar structure, and maybe at position 1 they also have an aldehyde group, and then you can say, okay, there is also an aldehyde group. The possibility or the likelihood of this compound being a skin sensitizer is very high. So this means QSAR models. And most of those models which we are using are such QSAR models. So you want your prediction to be accurate, of course, and this needs a lot of regulation. Actually, you need to perform your experiments as accurate as possible. You need definitions on your results. So when you have results based on your assays, how can you use those results to score your chemical, and also to score it or classify it as a sensitizer or non-sensitizer. And this regulation exists. It's actually a very detailed regulation done by the OECD. It's the OECD 497 guidance. This describes the whole process of skin sensitization assessment. There are 3 sub-guidances on the 3 assays which I have shown you before, on the 3 different key events. So the DPRA assay is regulated by a specific sub-guidance. The keratinosense and the HGLAD are all regulated. So this includes sample preparation, experimental conditions, and how you have to interpret your data in the end as well. Within those regulations, you come up with a lot of definitions and words and phrases. Some of them are very important, and you see them quite frequently and quite often. I want to give you a short definition of the most important ones. There are other important ones as well, but I think those give a good insight into what we are doing as well. So if you're doing a prediction, you can get a positive result or a negative result for skin sensitization. And this prediction can be accurate, or due to some failures of the model or something, you could also get a non-accurate result. So you can have true positive results, or you can have false positive results. The same holds for your negative results as well. So you can have true true negative results and false negative results. And based on this principle, you have the sensitivity, specificity, and accuracy, which are defined as you can see here. So sensitivity is the number of your true positives. So you have positives and they are the reality, they are real positive, divided by the number of all positives chemicals, also the ones which you do not know yet, so the false negative ones. Specificity is the number of true negatives divided by the number of all negative chemicals which you have. Accuracy is the number of all correct predictions by all predictions you've done. And accuracy is actually um, the average accuracy which you have. Then defined approach is an important phrase. Defined approach is an approach which you follow during the assessment process and which is also regulated, for instance, here by the OECD guidelines. I just read it out. So a defined approach consists of a fixed data interpretation procedure applied to data generated with a defined set of information sources to derive a prediction. And this you can do in an integrated approach to testing and assessment, meaning if you have one in silico model to predict a chemical and you do a prediction, can you rely on that result? Most probably not. You do you run several models, you consult existing experimental data coming from in vitro data, maybe existing in vivo data as well, and you integrate all the data which you have and compare the results so that in the end you can make a most accurate prediction. So I also read this shortly. So a structured approach, IATA is a structured approach used for hazard identification, characterization, and/or safety assessment of a chemical or group of chemicals, which strategically integrates and weights all relevant data to inform regulatory decision regarding potential hazards, risks, and the need for further targeted and therefore animal testing. Now we come to the classification and scoring of the chemicals, and for this, I just want to give you a short insight on how the assays work. So the DPR assay, as I said, it's the binding capacity which you measure for compounds to cysteine and lysine containing peptides. You just expose your test chemical to a solution at 22.5 until 30 degrees Celsius for 24 hours, and the binding you measure by HPLC. And the outcome is your binding capacity of a compound, meaning how good has your compound bound to cysteine and lysine, meaning that if you have a 98% binding protein depletion, that 98% of your compound has been bound to cysteine and lysine. In the DPRA assay, a chemical is considered positive for skin sensitization if the mean peptide depletion is above or equal to 6.38%, or if you co-elute it with lysine, then above 13.89%. The keratinosens is this gene expression assay, where the binding to the KEAP1 sensor is measured. This is also a covalent binding to cysteine. It releases expression factor for ARE genes, which express the ARE protein, which is an antioxidant to deal with cellular oxidative stress. And it is linked to a luciferase marker, which you can detect by spectrophotometry. You incubate for 48 hours, and the compound is considered positive when the luciferase expression is 1.5-fold to the control at the concentration where you see more than 70% cell viability. So with this assay, you get a specific concentration, which you see both of these factors are true. The HGAT assay is also a binding assay. You incubate for 24 hours to dendritic cells. You get the expression of CD54 and CD86. You use antibodies against the proteins, wash away the remaining proteins, and you can detect the proteins or the labels at least by flow cytometry. In the HCAT assay, compounds are considered positive when the fluorescence intensity for CD86 is 1.5-fold and for CD54 2-fold compared to control, and where the cell viability is bigger or equal to 50%. So you have 3 assays now, and you have results in percent, in micro, in a concentration unit as well. And now, how should you go about it? The OECD has tables. You see here, this is a classification table. And you have 2 approaches which you can follow. First of all, you have a 2 out of 3 approach, meaning you have to conduct all 3 assays. If 2 out of those 3 assays gives you a clear, non-contradicting result, you can take this result either positive or negative. But this is not enough. This here, what you see here, is the second approach, meaning you take the assay from the first key event and from the third key event, and you integrate it with a QSAR in silico prediction. So this QSAR in silico prediction might be the OECD QSAR toolbox, and it says you, okay, it is a sensitizer or it is a non-sensitizer. And based on your results, which you got from the assays, maybe here you got a 14% cysteine depletion, then you score your chemical as 1 for DPRA. Here maybe it might be a 2 for HGLAT and a 1 for QSAR. Then you have a second table, and then you see, okay, our in silico prediction is in domain, meaning you can apply your in silico model for that compound. And then you can sum up your scores which you got. So 1 plus 2 plus 1. So we have a score of 4. And then you see the chemical can be classified as 1B, meaning it is a weak or moderate skin sensitizer. 1A means strong sensitizer, 1B moderate or weak sensitizer, and non-classified does not mean that it is a negative prediction, it is just not classified. So you have those 3 classifications. You might have the case where the in silico prediction is not in domain. So if you train a model on aldehydes and you do it for 10 years and then suddenly you come with a hydroxy group, this means that you can maybe not apply this on aldehyde group trained model for an alcohol group. So this means not in domain for the compound. And you might have the case where your in silico prediction is in domain and one assay is applicable, then you have to follow this procedure. But in the end, you get a score and you can classify your chemical based on this procedure as skin sensitizer or skin non-sensitizer and even strong, weak, moderate sensitizer. This approach we implemented in our approach to testing and assessment in concern of skin sensitization. It is called SaferSkin on our platform, which we do not only follow the OECD guidance as I have explained to you right now. Our aim is to further integrate also other tools, so other models, to further underlie the outcomes, predictive outcomes which we get. And beside this, we also try to manage the data in an organized, very good way. We also always say these FAIR principles, findable, accessible, interoperable, and reusable manner, which is important. We try to offer, besides the OECD recommended in vitro assays, modern other in vitro assays which we can implement. So for keratinosense assay, we, for instance, also offer the Sense-IS assay for the second key event of skin sensitization. It measures 61 different genes which are all expressed during skin sensitization. This we implement in our in silico modeling work, and use this, of course, to do case studies. Case studies meaning we take compounds and predict them, and also write a report on them, and visualize the results in a nice way. We have good expertise, which help us on it as well, in form of partnerships. So we can offer this expertise and implement our services on platforms such as SaferSkin, the application, for instance, to offer solutions to replace animal experimentations and for green goal purposes. This is actually the aim. And with this in mind, we are happy to join different European Horizon projects at the moment, which actually have this goal or are following this goal. So for instance, Risk Hunter, which is part of the ASPIS cluster, which are developing prediction tools on the consideration of the 3R principles, as you can see here, for animal welfare and for green goal approaches, and the Accords project, where we develop tools to characterize 2D nanomaterials, image-based. We just recently started this January the Safe and Sustainable by Design project for Chem project, which also goes into this direction. Our services are actually findable, and you can use them as well. You find them on our portal. It's Safe World by Design, where you have the solutions area. You can also get consulting or ask questions if you want. We have a shop where you can actually order the assays, which I just have presented to you. So we have the DPRA, keratinosense, HClad assays, all the in silico modeling as well. But we also have tissues, we offer cell cultures, a lot of many things actually. And if you're interested, you can just go to the shop and have a look at it. When you go to the solutions to the SaferSkin area, there you find the SaferSkin application. We will have a look at it shortly in a few slides, where we can actually do a short assessment together of a chemical of interest. You see, it's actually a step-by-step procedure, where you, in the first step, enter your compounds. You can enter by SMILE structure, or you can draw a molecule, or you can even choose from a list. And then you assess your chemical based on our models, which we have implemented, make a prediction. You get a prediction overview, and you can also get a report on your prediction, which you can use for your reporting to authorities. We have already done quite a lot of case studies. Those are example compounds which we have done, with SaferSkin 1.0 actually. And you see, for some of the compounds you got quite uniform, good results, and for some compounds you get contradictive results. This is a case which you often see when you use different prediction tools, that you get predictive results. And this is a problem actually, and a concern which is trying to be solved, and where people work really hard to make it as accurate as possible. Notch et al. Have actually suggested on how such models and predictions in general can be improved. So there are 4 points, for the most important ones, I think. You can increase your prediction accuracy by better understanding the molecular mechanisms. For instance, if you would do a model on Alzheimer's disease or neurotoxicity, I mean, the molecular mechanisms which lead to that disease are still not really, actually still not known. So it would be very hard to do a prediction tool for neurodegenerative diseases. So we need to understand the molecular mechanisms to be able to build models. We can improve testing schemes, make it more uniform, more regulated, maybe also less regulated if it helps. So also here we have to find the best way to get the most accurate results. we need to use a variety of different models. This is this integrated approach we are talking about, and use as many data sets as possible from which you know that you can trust the data. This is also very challenging. What data can you trust? Which data set should you use? So this is also a very important point to consider. And also solubility issues I listed here, because some assays are done in acetonitrile or funny solvents. We always have to remember that our organisms are water-based, and by changing solvents, you also change reactivity of chemicals. So if you do assays in acetonitrile, maybe you need to consider that reactivity might change, and that this influences the prediction result as well. So therefore, we try always to improve our tools which we have. And here you see we made some improvements from SaferSkin 1.0 to SaferSkin 2.0. We use, for instance, new predictors. So we used Chemaxon in the past. Now it's Opera. We included now Skin Doctor and the Forest prediction as well, and made a lot of changes. But I'm not the expert on computational science, but Tomasz luckily is an expert on computational science, and I think it would be a good point if you would take over and could give us a further insight, more deeper insight into the models. Tomasz, I will give over to you.
Thank you, Pascal. Hi, my name is Tomasz, and I work for Edelweiss Connect for a few years now, and I'm mainly dealing with modeling and data management. So I will give you some introduction or overview of models implemented in the SaferSkin application, and then Pascal will continue with a few case studies. So Pascal already introduced a newer version of SaferSkin application, and as we see in the older one, SaferSkin 1, we had 3 ITS, so integrated testing strategies for skin sensitization assessment. One was 2 out of 3, which is a simple rule, and then multiple regression based on the variation of kinetic DPRA, and the Bayesian network, which was the most complex one, and this approach was proposed by P&G, and we also implemented it using open source libraries in R and Python. In the older version, we had to use some commercial software like Chemaxon to predict physical chemical properties, and Times to predict skin sensitization potency. And we replaced in the newer version this commercial software with open source models. So we use now Opera as an open source suite to predict PhysChem properties, and Skin Doctor CP as a model, in silico model, actually QSAR model to predict skin sensitization potency just based on the chemical structure. We also extended the initial Bayesian network proposed by P&G with a newer with extended network that also implement kinetic DPRA as an input. Furthermore, we also added other defined approaches like the neural network approach proposed by Shiseido, and OECD ITS, so the simple scoring system that Pascal already talked earlier. And then we also implemented Skin Doctor CP model and a random forest based on the PhysChem properties. So just briefly, Pascal, you can go to the next slide. So here is just a few words about each of these models. So OECD 2 out of 3, it's just a simple rule for hazard classification based on the in vitro parameters. Then OECD ITS is a simple scoring system that can give you GHS classification, again based on the in vitro and also in silico parameters. And then we have the multiple regression model proposed by Giodan, and it's actually straightforward linear regression from in vitro parameters to the in vivo PEC3 value. So it already provides EC3 value, which is valuable for quantitative risk assessment. Then Bayesian network, this is maybe the most complex model because it's actually a model of all the correlations among all the skin sensitization parameters, so in vivo, in vitro, in chemical parameters, and FISCAM parameters. And it provides you with a probability for different outcomes given evidence. And evidence is very flexible. You can provide just in vitro parameters or in chemical or all together. And then the probability of the final outcome, so the in vivo outcome, changes based on the evidence that is provided. So this is one of the, let's say, advantages of this approach, that it gives you confidence and it is flexible with the inputs that you provide. Then neural network approach. So this is the more complex regression model that takes in vitro and in silico parameters as an input, and it can provide a PEC3 value, which is again useful for quantitative risk assessment. And Skin Doctor CP, this is a model developed by in collaboration, I think, by University of Vienna and Bayersdorf, and it's a random forest model based on chemical descriptors, and it predicts LLNA classification of the compound. And then we also implemented another random forest model, which is predicting based on the FISCAM parameters provided for your compound. And it can then classify it as the LLNA and GHS classification schemes. Okay, next slide, please. So this is an overview of what do different models provide. So for hazard assessment, basically every model can give you this binary classification, whether a compound is sensitizer or non-sensitizer. And then GHS classification, which distinguishes between strong and moderate or weak sensitizers and non-sensitizers, is another classification, so into 3 classes. And then we have LLNA classification into the 4 classes as per LLNA, and PEC3 value that is used for quantitative risk assessment. And as I said, all the models provide can be used for hazard assessment, and then majority can be used for GHS and LLNA classification, while only 3 of these defined approaches can provide also PEC3 value for risk assessment. So it's multiple linear regression, Bayesian network, and neural network. Okay, next slide, please. Maybe just to illustrate what inputs are required from these different approaches. So, okay, we have seven approaches, but only 5 of them are like defined approaches combining in vitro and in silico parameters into that to predict in vivo outcome, while Skin Doctor is a Q-user model, so it takes just chemical structure to predict LLNA outcome, and FISCAM Random Forest is basically taking just FISCAM parameters to correlate them with the in vivo outcome. Um, yeah, so OECD 2 out of 3 and ITS, they are based on classical DPRA, keratinosense, and HCLAT. And OECD ITS can also use in silico, uses in silico tools, so you also need to know chemical structure. Then multiple regression model, it takes kinetic variation of DPRA, so either KDPRA or higher reactivity assay core 1 C420 and keratinosense and HCLAT, and also FISCAM parameter, as the vapor pressure turns out to be also a good predictor for the in vivo outcome. Bayesian network basically takes all of these parameters, and yeah, as I said, the advantage is that you can provide only subset of them if you have just some of them, and you will still get some outcome with maybe a weaker confidence in that in the prediction. And the neural network is based again on the DPRA, keratinosense, HCLAT, and also in silico tool such as times or tox alert. So you also need to know chemical structure. So this is on this slide we just briefly overviewed what are the inputs needed by different approaches. And so the SaferSkin application, as you will see later during the case study, combines all these approaches, and basically for a certain compound, you can get all of the predictions at once, which can be, again, interesting for the safety assessment. And maybe on the next slide, yeah, I have just some next steps, what we still plan to build into the SaferSkin application. So one thing is to extend multiple linear regression models to use those from the newer paper that are built on the kinetic DPRA instead of core 1 C420 assay. We also want to add support vector machine model for hazard prediction, as it has somewhat higher accuracy than the 2 out of 3 approach. And we also want to extend it with the batch processing functionality, because it will allow us then to, for example, evaluate, to easily compare all these models on a set of compounds. Because right now you basically enter data for a single compound and you get all the model predictions for that compound. But it would be actually very interesting to see how do these models perform if you provide, I don't know, 100 compounds, just to see for the ease of comparison of these models. And we are also building a skin sensitization database that would be then used for training of these data-driven models and also for evaluating them. So this is more in light of making these workflows transparent and reproducible. Yeah, so with that, I would ask Pascal to continue with case studies.
Okay. Cannot make it too long, the case studies, but I think it would be nice to also for you to see the application, and I can show you how it works and show you the first steps. So this here is the link. If you want to, you can now do it with me together. You can go to saferworldbydesign.com. I leave now the PowerPoint and go to my browser. So you can actually in Google just look for a safer world by design. Give some seconds for those who are following as well. If you find safer world by design, Just go to the portal and you will find yourself on our home page. On our home page, as I have shown you before in the image, you have a consulting desk, the shop which you can explore, some news. So the ongoing webinar is in this category, for instance, some description about us and our partners which we have, and you can just browse around. Now we want to go to solutions, where you see all the solution areas being developed. So SaferSkin is the most developed one, where we can go now. So you go to SaferSkin, where you see explore the SaferSkin application. So we go and click to this explore the SaferSkin application, and you will see yourself in the environment of the SaferSkin application. So now we have different licenses which we can use to use this application. As you can see here, for me it's a professional one. You might have the demo version. For the ones who have not logged in yet or signed up, if you want to use the basic version, you can, on the top right side, there is a button where you can create an account, a profile, and with which you get a demo version and not the basic version. For the ones who would like to do this now, they can do it now and sign up, so that you can follow along with the basic version. I will wait some seconds for this as well. Meanwhile, I would show you the features of the professional version as well, but we'll choose a compound which you can also choose in the basic version as well, so that you can do it all together. I think you have to give your email address as well, your name. So in the basic version, what you can do is you can choose from a list of compounds. We have assessed some compounds, which you can see here. And if you click on one of those compounds, let's say, for instance, safranal, we can take. It already takes it as an input and also gives you all the parameters already inserted as input. So you see here for the OECD 2 out of 3 approach, the experimental results are in. Also for the integrated approach here, DPRA H-cloud results, the OECD QSAR prediction is in. Multiple regression, you also need to input the vapor pressure, KDPRA, as Tomasz explained before, again keratinosense assay. We have the neural network, DPRA, keratinosense H-clot, times prediction in toxtree, which you need to give. Then the Bayesian network with the molecular descriptors, water solubility, then the oil-water parameter and protein binding capacity. Again, the 3 assays and the times prediction. This is already filled in. And then you could make a prediction. Now, if you use a professional version, for instance, you do not need to choose from the list, but you could also go to PubChem, for instance. Search for any compound. Then you can look for the SMILES structure. Just copy your SMILES structure. You paste it here in the SMILES input panel, and you see it's already detected. And you can make a script prediction. And you see here now for a new compound, those fields are all empty. So either we have the data from literature or conducted by ourselves, and we have to fill in this data to make a prediction for some models. Some models, such as the Bayesian network, they can make predictions also without input. So if you make a prediction, you get a prediction for the Bayesian network. Here's, yeah, we first have to predict the parameters. I'll put some in as well. Yeah, so you need to know the molecular parameters, and then you can make a prediction also without the in vitro assay results. And you can get a report. You can also draw a chemical. So if you go back to PubChem, to the 3D structures, for instance, you can get the SDF. You can go back. So either you draw a molecule by hand, or you just draw and let it go, and then it is automatically recognized. You could do the same as before and make a prediction. Now let's take a compound which is already assessed, such as the safranal. You can make a prediction, and you see for each model you get a classification, 2 out of 3. This is the OECD approach, which I have shown you before, the ITS, multiple regression, neural network, and the Bayesian network, where you get also a prediction confidence. With the basic version, there is no possibility to get the report, but here you can, with the professional one, you get the report, and you have all the summary of results and a very nice overview, which you also can print out and save for your records, and also to report to authorities as well. So this is the SaferSkin application in short. As I said, you can try it out, explore it. If you have any questions, you can write us at any time. We are happy to help you with it and to make your predictions and help you with your predictions as well. Yeah, hopefully it helps you in your decision-making concern of chemicals and compounds as well. Yeah, I think at this point I would leave it up to you to try it out by yourself, and would open maybe the question and discussion panel, if that's okay for you, Barry, and then we can discuss and answer questions if there are any.